Good morning, you guys. Okay, so happy Monday. We've got our test today. So what I'm going to do is go over the multiple choice questions that I posted on Friday. The test this time around is going to be all multiple choice. So most of you, I think, will like that. Best of luck. Let's go over this, and then I'll open this up and the test as well. Okay, so for the density curve shown, which statement is true? So for a density curve, right? So as a review, it has an area equal to 1, and it's above the x-axis. That's it. It doesn't have to be symmetric, right? It could not be symmetric at all. But these two facts always happen with every density curve. Okay, so this one is normal. Well, we don't know that, right? So it didn't say that it was normal. Just because it's a density curve does not mean that the distribution is normal. So that's not correct. The density curve is skewed to the right. It doesn't look like it. The mean, the height of the curve is 1, so the mean would be right in the middle. We don't even know how high it is, right? So that doesn't make sense. It is symmetric, yeah. Right? Pretty straightforward, pretty simple. This is really the review piece there. Okay, so for that same density curve, which one is true? The mean is greater than the median. No, it's not less. They are equal. Right? When you have a symmetric distribution, by definition, your median and your mean will be the same thing. Okay. All right, so suppose a 16-ounce bag of chocolate chips are produced with weights that follow a normal distribution. Okay, so now they're telling us that it's normal. And when they tell you it's normal, you know that the distribution follows that 68, 95, 99.7% rule, which tells you that if you were to draw a symmetric curve, because all normal distributions are symmetric, with an average of 16.1 and a standard deviation of 1, when you go out standard deviations on a normal curve, you just add 0.1 or you subtract. And I only went out 2 standard deviations. And the question says, well, what percent of bags lie between 16 and 16.1? Okay, so we're trying to find the area, okay, the size of that. And that would be a proportion, which is a number between 0 and 1. And this rule tells us if you go out 1 standard deviation in each way, you capture 68. So this must be half, because the other 34% would be over here. Okay, so 34% would be your answer. All right, for number 4, the distribution of cookie bags described above, what percent of the bags will be underweight less than 16 ounces? Well, if you draw that again, and your average is 16.1, and you come down here to 16, now they want to know, well, how many bags, what percentage of bags are less than 16? Okay, well, let's do the same thing. We know that this is 50% to the right and to the left, okay, because that's the center. We just said that this was 34%. And so what's left over, if this whole side is 50, what's left over would be 16% for an answer of B. All right, so then some statements here. So which of the following are true? The area under a normal curve is always 1, regardless of the mean and standard deviation. Yeah, if you have any density curve, it's the area is always 1, right? That's from above. So that is definitely true. The mean is always equal to the median for any normal distribution. By definition, normal distributions are symmetric. There's other things, but it's definitely symmetric, which again tells us you have mean and median that are the same, and so this would also be true. The IQR extends from 1 to the left, 1 standard deviation to the left of the mean, and 1 to the right. Well, that's not true, right? This is 50. This, if you subtract 34, this is at 16%. That's not quartile 1, so that doesn't make sense. So the answer here would just be 1 and 2. Okay, our last one, okay, which is going to be using table A, the proportion of scores in a standard normal distribution that are greater than 1.25. And so what you do here, right, it says standard normal. That means you're going to do the same symmetric graph, but your mean is 0 and your standard deviation is 1. And so we're looking at 1.25, and you want to know what percent is bigger than that. Okay, well, let's go back here and talk about table A. Okay, table A, in the very back of your book. okay, tells you these numbers along the edge are z-scores, right? You make a z-score, and then the numbers in the middle are proportions. That proportion represents to the left of any z-score you find. And so if we were going to go to 1.25, there's 1.2, there's 0.05, you come down, you go over. 0.8944, let me show you visually, is this side. 0.8944, that's from table A, is the area to the left. And so this little piece is 1 minus 0.8944, which would be, 0.1056. Okay. All right, you guys. So multiple choice questions. If you're worried about it, what can you do? It's 2 sections in the book. You guys should definitely go back and read the text. It would take you maybe 45 minutes to read the entire chapter and to remind yourself of vocab and stuff like that. That's what's going to be most helpful on a multiple choice test. All right, you guys. Happy Monday. Best of luck. See you guys tomorrow.